This question we're told dowsing, if you've never seen it, is someone going around with a piece of wood telling you what's underground. It's amazing to see. It's a type of divination employed in attempts to locate groundwater, buried metals or ores, gemstones, oil, grave sites, etc. Imagine being a dowser. What do you want to be when you're older? I want to be a dowser. A person who practices dowsing is known as a dowser. Dowsers claim that the forked stick they carry vibrates when something of interest, such as groundwater, is located directly below. In a rural area, about 30% of the wells drilled find adequate water at a depth of 35 meters or less. 35 meters or less. 30%. A local dowser claims that he is able to find water with a forked stick. A survey of 80, he got a lot of customers, randomly selected customers, reveals 27 have wells less than 35 meters in depth. 27 of Dowserman's 80, which is equal to 0.3375. So is he more successful than drilled wells or other people doing it or finding it? Test the hypothesis. So we have a proportion here, 27 over 80. So if we multiply 1.96, we'll do it as a population proportion. We could have set up a confidence interval too, by, well, 0.3375 or 27 over 80 times, well, it's going to be 53 over 80. I'll put them both in as a fraction. It looks a bit ridiculous. 27 over 80 p. 1 minus p, 53 over 80, divided by the sample size of 80. It's going to give me a big-ish number of 0.1036. So if we take my p of 0.3375 and add 1036, I'm going to get 43, 44, 11. 0.4411, and on the other side, taking away 1036, I'm going to get 23, 39. So what's this telling us? So 0.3 we were testing it against, and because you can see that low sample size of 80 here is going to, well, the 30 lies in here, but what if this number here was, let's say this number was 800. If I put that into my calculator with a larger sample size, which is the way they can change these questions, I'm going to get this number to be 0.0327. Now I'll just take the 0.03 bit. We don't need the 27 part, but we'll have a look here. Now p becomes 0. If I add, I'll take the 33 of both, 0.3675. If I add 0.3 on, if I take 0.3 away, 0.3075. So a sample size of 800 with the same success rate, it'd be 270 over 800, which would still be 27 over 80. It wouldn't change the p and the 1 minus p, but the sample size, the greater sample size, would give me a different error here, or a different margin of error to add on and subtract. So for the question, the dowser is the same success rate as the drillers. We can't have any other evidence to suggest otherwise. And question 12, according to the National Business Travel Association, my wife tells me I need glasses, the average salary of a travel management professional has disappeared. It's 97,300. Assume that the standard deviation of such salaries is 30,000. Consider a random sample of 50. And what is the mean of the sampling distribution? What is the mean of the sampling distribution of the sample mean with a sample size of 50? Okay, we have an average 97.3 standard deviation of 30, and we have a random sample of 50. N is equal to 50. And we're asked the mean of the sampling distribution of the sample mean with sample size 50, but we've no other evidence to go on to say that the mean is any different, so the mean is going to be the same, 97,300. The standard deviation is going to be the same too, it's going to be 30,000. The standard deviation of the sampling distribution is your 30,000, your sigma divided by root n. So this sample size is 50. So the standard deviation of the sampling distribution, 30,000 divided by 7, 4243 in dollars. Describe the shape of the sampling distribution. Well, it's going to be normal with a standard deviation of our new guy here. Sketch it. Okay, let me sketch our normal distribution. So we have in the middle, we have our 97,300, our average. Do we need to do all standard deviations? Well, I'll put in the, let's say that's 1. Get some symmetry. 2. And try and get down a bit for 3. And they will be looking for the numbers here, so just add on 4243 once, twice, 3 times on both sides. There's no need for me to do that here. I'll do it 3 times anyway to give you the end of it is 110,029, and the start of it 84,571. Fill in the other numbers along to get your plus 1, 2, and 3. And that's the sketch. Find a z-score for a value of 89,500 for the sampling mean. 89,500 is what we're testing against our average of 97,300. We're dividing by sigma over root n, which we already have, 4243. Minus 1.838. We got minus 1.84, so close to 89. Sorry, 1.84. And 1.84 is 9671. So what are we asked here? To find a z-score for this value. Well, our z-score we have there minus 1.84. And the probability that a random sample of size 50 will have a sample mean of less than this. Well, we're looking for the tail. Just do a sketch. We're testing on the left hand side, aren't we, here, of 89. We're testing over here, so we want this bit in here. We do want the tail, which is 0.0329. Just use your calculator, but you should be able to add these two together. And if they ask for that as a percent, it'll be 3.29%.